Okay, so objective. Today what we're going to do is we're going to be doing a phase shift and a vertical shift of y equals sine of x and y equals cosine of x. Okay, so just start there, okay? Write that down. And before we even begin, on the very top, we're going to take a look at our two main graphs. So let me get out my old notes, because we've got to know what the main graph looks like. You can't move the graph unless you know what the graph looks like, right? So in my notes, because I take good notes, right?
Of course.
Okay. So Friday, when I was gone, I made some beautiful notes. That is a sine graph, right?
Yes.
And that is a cosine graph. So what I like to do is, up above, real quick, I'm just going to put the general shape. I know that sine looks like this. That's y equals sine of x, pi, 2 pi, right? And my cosine looks like this. And this is a y equals a cosine of x, pi, 2 pi. All right? I've got the general shapes. If I can see the general shapes, then I know what I'm going to do, okay? So first of all, vertical shift. That's just an up and down, okay? That's going to be your value d. So if I have a y equals a sine of b times x minus, and they say c over b, but I'm just going to call it c plus d. My vertical shift is the opposite of c. Opposite of whatever value is right there, okay? That's going to be my, oh, I said that wrong. It's a vertical, not the phase shift. It is not that. I've got these backwards. Sorry, Zoe. Vertical shift is just d. It's the value. It is just d. It's going to be an up or a down. And it is that one. There you go. My bad. Now, the phase shift is the back and forth. So the phase shift is the opposite of c, which is that value. Now I got it right, okay? And I like k instead of c. I like the b on the outside parentheses. Okay, and if it's not, then we'll have to fix it, okay? So let's look at example 1. Slide it up. Take a sine curve. Watch my finger. Sine curve looks like this, right? I'll do it again. Watch my finger. Take a sine curve, right? And make sure it's height of 3. Goes all the way up to 3, down to 3. And then I'm going to move it pi eighths. So when I trig graphs, I always try to make squares of 4. And you're going to see why. Okay, so I'm going to make sure I go 1, 2, 3, 4. And I'll have to call that probably pi. Oh, let's go pi fourths. 1, 2, 3, 4. There's my pi halves. 1, 2, 3, 4. There's my 3 pi fourths. 1, 2, 3, 4. There's my pi. 1, 2, 3, 4. There's my 5 pi fourths. And I should have made this graph longer. 5 pi fourths. Unit circle. This is my 3 pi halves. 7 pi fourths. And I'll finish it with 2 pi. Okay? So we're only going to look at a part of it. I probably should have changed these. I'm going to change. Do you guys use pencil or pen? Probably pen, huh?
Pencil.
Well, we'll just go from here. I should have made those pi halves. Would have made it better.
No, unless you give me the
I have one more, just one more. Pi halves, pi halves pi, 3 pi halves, 2 pi. There we go, that's what I want.
Wait, so it's pi halves and then pi?
Yeah, pi halves pi.
3/4 pi.
Yeah.
Pi.
Yeah. There's that. There you go. Alright, there we go. Pi halves, pi, 3 pi halves, 2 pi, which is from the unit circle, right? 0, pi halves, pi, 3 pi halves, back to 2 pi, okay? In pencil, we're going to look like this, okay? So my normal sine curve looks like this, pi, 2 pi. So I'm going to put in my normal pi curve first, and it's going to go a height of 3 to -3. And it's going to look like this. And you guys did this on Friday, right? Got it. Okay. That's just a standard sine curve. That's all it is. Standard sine curve. Okay. Now we're going to move it. We're going to go right pi eighths. Okay, we're going to go to the right pi eighths. And the right because it's the opposite, right? So it's got to be the opposite. Now, since I changed my squares, this is pi fourths. Does that make sense? That's pi half. That's pi fourths. We got that? Does that make sense? Which makes this pi eighths. So on my graph, 1 square represents pi eighths. We got that?
Yes.
And then we're going to take my graph and just move it pi eighths. So here's my answer.
Wait, where's pi eighths?
Pi eighths is 1 square. Let me show you again how I got that. So if this is pi halves, then half of that is pi fourths. Half of pi fourths is pi eighths. So pi eighths is here. So let's move the whole graph over 1. This point goes here. This top point goes here. This x-intercept goes here. This minimum goes here over 1. And this, so the entire graph got bumped to the right 1 square. Because 1 square is pi. So one more time. Here is my 1 sine curve. Pi eighths is 1 square for my scale, for this scale. So I took my whole entire graph, I'm just moving it over 1 square, which makes it look like this. And of course it keeps going and going and going because it's periodic. So we can put my arrows here, okay? How's that? Without messing up the scales, which I did. Wasn't too hard. Okay with that? Alright, let's move on to number 2. So to do number 2, I'm going to do 2 things. So it's going to be upside down cosine, amplitude 2. Okay? I'm going to put 2 curves in the space of 1, frequency of 2. Then I'm going to move it back to the left, pi fourths, and up 1. So, it seems kind of complicated. So I'm going to do this in a couple of different steps. First of all, let's go ahead and take a look at what an upside down cosine curve is. That's a y equals a negative cosine of x. All right, let's start there. So I took my standard cosine curve, which is this, and it's going to be upside down. Okay, so I've got that shape there. I know the amplitude of this one's from 2 to -2, so I'm going to go 1, 2, 1, 2. There's my amplitude. I need, let's go pi halves, pi, 3 pi halves, and 2 pi. Okay.
I have a frequency of 2.
So to do that, I just want you to watch my finger. Everybody watch. I'm going to have 1, 2 of them. I'll do it again. I'm going to have 1, 2 of them, right? So how wide is each curve?
Pi. And if you need help with that, there's a way to find the new period. So right up here, I'm going to say new period. And I had this for you on Friday. The new period is always 2 pi divided by your frequency. Always 2 pi. Always 2 pi, because that's the standard period, divided by the frequency, which our frequency is 2. So our new period in this case is pi. All right? So in pencil, because I'm going to move this, I'm going to look at my cosine. So here's my cosine shape.
Watch. It's easy. Watch. Everybody watch. Eyes up here. Okay, you see this thing? See this thing? It starts down. It ends down, right? Halfway through, at its halfway point, it's up. 1/4 of the way, it goes through the x-axis. 3/4 of the way, it goes through the x-axis. So I'm going to do a dot to dot and do that, okay? So I know that I'm going to have a, it's going to start down, I'll put a dot there, and it's going to end down, okay? So it's going to start at -2 and end at -2. Does that make sense? I'm taking this shape and putting it in here. Halfway through, it's at its maximum, so it's up here.
Wait, I have a really unrelated question.
Make it quick, because I'm in the middle of something really important. What?
Oh, wait, you're
Yeah, I'm recording. Okay, now, I know 1/4 of the way it has an x-intercept there. 3/4 of the way it has an x-intercept here. So you see my dot to dot? So I can just sketch that in, can't I? Now let's do it again. This shape here, right? It starts down, boom, and it ends down. Halfway, it's all the way up at its maximum. Its x-intercept is 1/4 of the way through, and its x-intercept is 3/4 of the way. So you see I got my dot to dot, and I sketch that in. Now that's done in pencil because I'm going to do a phase shift and a vertical shift, okay? So there's my standard curve. Now let's shift it. So do my shift. I'm going to move back, opposite. I'm going to move back. I'm going to go left, pi force. And I'm going to go up 1.
So I'm going to go and take this graph. I'm going to go to the left, pi force. So pi force is 2 squares. Can you see that?
Mm-hmm.
So every important point is going to go back 2 squares and up 1.
Oh,
And then
wait,
you got it.
why one?
Because of this one right here, Landon.
I know, but that's not the lines. That's irritating.
Right, so you have different scales. This scales by pi 8s, and this scales by 1s. So your scales are different. Does that make sense?
Yeah.
So what I'm going to do is move it back 2 squares, up 1 square. Okay?
So I know that, in fact, I'm going to put that in so you guys can see it. This is pi force, isn't it? Right? Pi halves, pi force. So let's move everything back pi force and up 1, which takes this one back pi force, up 1. At this point, back pi force, up 1. 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 Am I missing? Nope. Back pi force, up 1. Back pi force, up 1. Back pi force, up 1. And my curve should look like this. Okay, how am I doing? And that's my new curve. Turn the page. Does this seem easy? I'll wait for you. It really comes down to being able to put the 4 points down. Actually, it's 5 points. Once you get the 5 points, the dot to dot, then it gets easy, right? Okay. All right. Back side. All right. So, cosine. A cosine curve looks like this. a normal cosine curve looks like this. Okay, right? Yep. A normal cosine curve looks like this, okay? This cosine curve is going to go to a height of 4 and down to -4, because that's my amplitude, right? This is weird because the frequency is called pi force. Now that's a weird frequency. If the frequency is pi force, that's kind of weird. So what I'm going to do is find the new period, okay? This is my frequency. I know my amplitude is 4, but my new period, I need my new period. So the new period is always 2 pi divided by the frequency, right? Always 2 pi divided by the frequency. Here's my frequency. So if I take 2 pi and divide it by pi force, oh, let's see, that's kind of confusing, but I know that's like, if I divide, it's like the same thing as 2 pi over 1 times 4 over pi. Pi's cancel. And my new frequency, my new period, the period of this curve is 8. My new period is 8. And that makes sense to me. Because in a real life problem, the x-axis is going to be in terms of seconds or time. And you're going to have numbers like this in science because your number's going to be like half a second, 1 second, or 2 seconds, not pi's. But this is going to be in terms of time, right? So what we're going to do is go by ones. Not pi's, but 1, 2, 3, 4, 5, 6, 7, 8. So in science, think about these as being seconds. Or if it's a cell phone, nanoseconds, right? Because the waves are super small, right? So let's see, 8, 9, 10, 11, 12. Let's go out to 12. And -4, okay? I know my amplitude is 4, 1, 2, 3, 4. This is kind of weird because the scales are going to be the same, aren't they? Okay, there we go. So, first of all, in pencil, I'm going to draw in this curve, okay? Now again, here's my shape. I'm going to put it between here and here, okay? Here's my shape. I want to put it from here to here, okay? Let's do our dot to dot. Cosine starts up at its max, which is up at 4. So it starts at 4. Cosine ends up, right? So at 8, it's going to end up at 4. Halfway through, cosine's at its very minimum, which is going to be halfway through. It's going to be at -4. Okay? Its x-intercept, which is a fourth of the way through, is here. Its other x-intercept, was here, was 3/4 of the way, is going to go here. Okay? So one curve looks like this, but I haven't moved it. Okay, and I keep going and going. I can do that again if I want to, because why not? And I can keep going again. Why not? And I keep going again. Why not? Okay, so here's what it looks like. So in electronics, have you ever seen any of the waves before for computers? This is what it looks like. This looks like it could be off an oscilloscope or measuring electricity. So now, let's move it. Let's do a shift. So we're going to move it left 3 and down 2. Left 3 and down 2. Correct?
My phase shift is going to be opposite direction, back 3. And my vertical shift is going to be down 2. So take every important point and just move it back. 1, 2, 3, down 1, 2. Okay? So to finish this graph up, take every important point
And let's move it back. We're going to go back 1, 2, 3, down 2. We're going to go 1, 2, 3, down 2. We're going to go 1, 2, 3, down 2. We're going to go 1, 2, 3, down 2. 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 And it should look something like this. 1, 2, 3, 2, 3, 2. There we go. Am I off? No, I'm off here. Okay, there we go. And it should look like this. Thumbs up? All right. Number 4, how do you make a cosine into a sine? We saw that. We saw that a sine curve looks like this, pi halves. We saw a cosine looks like this, pi halves. That you can move the cosine curve, negative pi halves. You can take the cosine curve, y equals cosine, and you can move it to the right, pi halves. So if we have a y equals a cosine of x minus pi halves, these two, and y equals sine of x are the exact same graph, just by a shift of pi halves. And again, in science, you just don't see it, right? Okay. Last but not least, am I going too fast? Okay. I'll wait for you. Okay.
So, if you just take the cosine curve and bump it forward, pi halves becomes a sine, doesn't it? If you take this graph, just bump it that much, these two graphs are the same, aren't they? And in science, you never hear in science. Mr. Massey will never say, hey, let's look at a cosine wave. He's never going to say that. He's going to say, let's look at a sine wave. And you might say, no, Mr. Massey, that sure looks like a cosine wave to me. And he's just going to smile.
So, last but not least, here it is. Now for us, we can do a cosine, okay? So let me ask you an easy question. We want to make the equation. The easiest curve to make is a cosine. You know why? Because I can find the top. I want to call this a cosine curve. 1, 2, let's see, 1, 2, I think it's right at 3. 4, 5, 6, 7, 8, 9, 10. I think it's 11. Okay. So one cosine curve. There it is. Hey, that does look like that, doesn't it? Doesn't it look like that? It does, right? So first thing, when you make an equation, you got to ask yourself: is it a sine or is it a cosine? Cosine is always the easiest to call because you can always find the top. Does that make sense? To make it a sine, you can find the very middle, which is probably right about here. If you want to call it a sine. So let's start there. Let's start. Okay, I'm going to call y equals some cosine of x. Let's start there. Okay. What's the amplitude?
8. No,
That's period, but good. What's the amplitude?
5.
Looks like it's up.
5.
I don't know, 1, 2, 3, down 1, 2, 3. But if you're not sure, the way you find the amplitude is the max minus the min divided by 2. That's the easiest way to find the amplitude, is just the max minus the min divided by 2. And I gave this to you on Friday. That's okay. So the max is, let's see, 1, 2, 3, 4, 5, minus the min, which is a negative 1 divided by 2. Okay, I'll do it again. Max.
If you can't figure out what the amplitude is, it is up 3, down 3. But if you can't see that, it's always the max. 1, 2, 3, 4, 5, minus the min, minus the negative 1, which is a 6 over 2, which is a 3. But hopefully you can see the 3. Do you see it goes up 1, 2, 3 and down 1, 2, 3? So let's rewrite this equation. Y equals 3 cosine of x, okay? Now we got to find b. B is a frequency. So to find b, you take 2 pi, always, divided by the period. So you've been telling me the period. What's the period?
3.
8.
Oh.
Right? How wide is this? The period is how wide. So the period is 8. So b, which is the frequency, is 2 pi divided by 8. What's that make? Pi fourths. So here's my new equation. Y equals 3 cosine of pi fourths parentheses. Now, x, we've got to have x value. Did this curve get shifted? Well, I think so, because cosine starts on the y-axis right here, doesn't it?
Mm-hmm.
But this one got moved. How far did it get moved? Got moved 3, didn't it? So it got moved 3 to the right, but it's always the opposite. So we're going to go minus 3. And then finally, did this curve get bumped up or down? How much? 2. Do you see the midline? Now, if you're not sure what the vertical is, the vertical shift, if you can't see it, it's always the minimum plus the amplitude, okay? Always. And our minimum is -1. And our amplitude was 3, which puts it at a shift plus 2. This is the equation of that graph. Whew! Big day, huh?